Hi, I'm Ryan from Cyborg Dynamics Engineering. Today I'll be demonstrating how to install and use our Windows port of CAN-utils. CAN-utils is a toolkit widely used on Linux for inspecting, testing, and debugging CAN networks. It's a staple in many automotive and robotics workflows because it makes it easy to monitor live CAN traffic, send test frames, and troubleshoot communication between devices. Our goal is to bring the same capability and flexibility to Windows, so you can use familiar tools like CAN dump and CAN send without needing to switch to a Linux environment. It also enables our side-of-viz CAN visualizer, so if you prefer a graphical interface over command line tools, make sure to check that project out too. In this video, I'll walk you through how to install and use CAN-utils for Linux, set it up with your CAN interface, and I'll run a few examples to show it in action. I'm starting from the software page of our website, which will be linked in the description below. You can see here at the top is our side-of-viz tool, which actually uses win-can-utils on the back end to support Windows, and it also works on Linux using just their CAN-utils. That's essentially a CAN visualizer tool. Check out the video on that if you want to see how to use it. So if we scroll down further, you can see the win-can-utils section. This is just a brief summary of what it does, but what we really want is the link to the GitHub repository, which is in the download section here. Once you're on the GitHub page, you can scroll down to see the README section of win-can-utils. This gives a pretty thorough rundown of how to get things working, and it's what I'm going to be going through today. I'd recommend checking this out if you run into any issues, because things might have changed since the video has come up, so the latest information will be available on the README. We only support a couple of CAN adapters at the moment, but we made it a point to support an open source one, the Cannable adapters. You can get these quite cheap. The ones we use are these DSD Tech SH-C30As. I would highly recommend this adapter if you're going to use our software, just because it's going to have the best compatibility because it's what we've tested with. As you can see here, it's only $20 Australian for us on Amazon with pretty much next day delivery. The other CAN adapter we support is the PCAN adapter. We mainly supported this one because they have a really easy to use Windows library, and we already had a few of them because they were what we were using to debug CAN devices on Windows before we made our own tools. As you can see here though, the price of the adapter is quite a bit higher than the open source Cannable ones. Looking back at win-can-utils, we're just going to run through the installation of win-can-utils itself. So to do that, we're going to jump to the installation section, and there's only 3 steps here. Step 1 is to download the latest MSI installer from the releases page. Then we just run the installer, and if you want to use a PCAN adapter, all you need to do is download this DLL and drop it in somewhere with the win-can-utils. So I'll run through all 3 steps. If you're not using the PCAN adapter, you can just skip the last one. I'm just going to go to this releases page and download the latest MSI, which is currently version 0.1.7. With that downloaded, I'm just going to run through the installation very quickly. I'm just going to use all the default settings. If you want to change anything, you can, but importantly, you need to have the path environment variable set to wherever it's going to be installed. So if you run through the default settings, it should do that for you. So install and done. So now I've got win-can-utils installed. I can check it's installed by opening up a command prompt and typing in one of the commands. So I'm going to type CAN server, and you can see it's come up with the help for the CAN server command here. Now we've got win-can-utils installed, I'm just going to run through the next step of installing the PCAN driver. If you aren't using a PCAN adapter, you can skip this and move on to the next section. The PCAN basic dependency section runs through how to install the driver. All you need to do is go to PCAN's website, which is linked here, and scroll down to the download section and download their PCAN basic API. And there we go, we've got it downloaded. Just open it up, grab the DLL. If you're running 64-bit Windows, you'll need to get the x64 folder, and this is the DLL we want to copy. So if I open up a new Windows Explorer, I'm just going to navigate to where win-can-utils got installed. So that's under C, Program Files, win-can-utils. Open up the bin folder, and we're just going to drop PCAN basic in there. And that's all we need to do to install PCAN. I'm just going to run through how to install the latest firmware on a cannable device if you're using one. These instructions are somewhat tailored to the device we have, so if you're using a different one, they may vary a little bit, but this will give you the general idea anyway. So in the cannable firmware installation section, you can just read through the instructions here. We made a flashing tool for the device we use. It has a STM32F072 microcontroller in it. If you're using a cannable device with the same microcontroller, you should be able to just use our tool. The reason we made this is because we know this flashes the latest version of the cannable firmware, version 2.0. This is the most recently released one on the GitHub page for that project. I will mention there is an alternate flashing tool on the Cannable IO website. I've got it linked on the README here, but if we open it up, the device we use can be flashed with this older firmware, and the firmware file you'd want to choose is this Candlelight one. The reason we made our own flashing tool is because I could not find any reference to this Git hash, and I wanted to make sure we knew what version we were flashing with. So if you look at our flasher, you can see the exact version that's getting flashed is this link here, release version 2.0. We're going to jump back into the win-can-utils README and run through the flashing steps section. I set up a camera on my desk so you can see what I'm doing. Starting with the adapter unplugged, we're going to toggle the boot switch into the on position as pictured. And then we want to plug the adapter back into the computer. This device has just a red LED that shows up when you do that. We'll open the cannable flashing tool and try to flash the firmware. You might get this if there's no devices found. It just means you need to install the driver. So I'll run through that section quickly. Back to the README, we have the installing WinUSB driver section. To install the WinUSB driver, open up Device Manager. You can do that by following the instructions here. And you'll see the device appears in the Other Devices section with a yellow triangle next to it. That just means the driver is not installed yet. As you can see in step 3, we just need to right-click on the device and select Update Driver, browse my computer, let me pick from a list, and scroll down to Universal Serial Bus Devices. It's very similar to the one above, just make sure you're clicking on the right one here. Go to the next step, select WinUSB device, next, yes. And now you can see we've installed the driver, WinUSB device. It's going to show up in the Universal Serial Bus Devices section. With the driver installed now, we'll jump back to the flashing instructions. So we're going into the flasher, hit flash STM. You can see it's now showing up with the driver installed, and I just need to hit connect. That's going to automatically flash the device, give an OK message, so we can jump back to the next steps. Now that we're flashed, we'll set the boot switch back to off position and unplug and replug the device. If everything's gone well, you'll get a couple of green light flashes and then it'll stay on solid. Now you've got your device set up, I'm going to jump back to the usage section and run through that, showing you how to actually use win-can-utils. So first thing we want to do is start a command prompt and open up a server for the CAN device. So the command we're going to run is just CAN server, and I'm just going to show you the help page for that. You can see we need to type in a driver, and the supported drivers are GS-USB, PCAN, and SLCAN. If you're using the Candlelight and you flash the firmware like I've shown you, the driver you're going to want to use is GS-USB. And obviously if you're using a PCAN adapter, it's PCAN. There is SLCAN firmware for these cannable adapters, but it's slower and it can't handle the highest data rates, so we'd recommend using Candlelight over that. The only other thing we need to set is the bitrate. The channel should auto-detect for pretty much any device you plug in. So I'm just going to run CAN server, GS-USB, and set the bitrate to 1 megabit. With the CAN server up, we get this message, created CAN server, CAN 0. Now, if we want to actually use the CAN server, we're going to have to plug some devices into the CAN bus. I've got a CAN network set up on my desk now. So what I've got is a CIDR IMU, a 6-way data tap, 2 120 ohm terminators, and the adapter plugged into it. So the CAN adapter is going to be receiving data from this IMU. Except for the CAN adapter, these are all devices that my company makes to make robotics simpler. We have all the interconnect, data taps, and devices available on our website. If you're into robotics, check it out, it might have something you're interested in. So with our CAN server running and something actually on the network, I'm going to start running a can dump command. So open a new command prompt and run can dump can 0. And there we go, that's data from the IMU coming out. There are also other options for can dump. If we run can dump help, you can see them here. The original can-utils has a lot more options. We are planning to add more features to win-can-utils as we go, but these are the ones we currently support. The SL CAN adapter can do hardware timestamping, so if I go can dump -H can 0, we now get a timestamp of the CAN messages from the adapter itself, which is fairly accurate, down to maybe 100 microseconds. You can also get timestamping from the computer with the -TA command. That's absolute computer time. This is less accurate because the computer has more jitter in its time measurements, so you might get within a few milliseconds worst case. Now I'm just going to run through using can send quickly. Open up another command prompt and I'm going to run can send help. And this gives you the structure for how to run a can send message. It's worth mentioning that we've built these tools to be as similar to the Linux can-utils as possible, so if you need help with these commands, you can look up instructions for using the Linux version and they should transfer over pretty well. So a valid can send command looks like can send can 0, then we put in the frame ID, so 7FF is a valid ID, hashtag data, so I'm just going to type in 1, 2, 3, 4, 5, 6, 7, 8, and hit enter. That's now sent the message 7FF with the data 0, 1, 2, 3, 4, 5, 6, 7. That's all the commands we have available right now. That can get you a really long way with can debugging. I'd highly recommend checking out our Cider Viz tool, which lets you visualize the can data much more easily and interact with it through a graphical user interface instead of using command line tools. That's all for this video. If you're into robotics and want to check out our products, the link to our web store is in the description below. Otherwise, stay tuned for updates to these open source tools. We are improving them actively. Thanks for watching.